All right. Hopefully you guys enjoy the last video. Today we're going to be going over a water meth injection blend setup. Previously I had made another video I was going to release, but didn't like the way it really turned out. So redoing it for everybody just to make everybody happy and have a good video to follow. So first we're going to start off. In the previous video I mentioned setting up 1 and 2. So you're just going to repeat that same process again where you just copy fuel map 1 to fuel map 2. In this case, if you go to fuel setup, I just have this as pump and this is water meth injection. Depending on the amount of water meth you're going to use, you may need to change your Stoich AFR because when you're injecting so much methanol into a system, you're effectively changing the point where Stoich is going to be, 14.7 to 1, right? Because everything that we do with the ECU is based off of lambda rather than AFR, as it's a more accurate reading and it's repeatable. So moving along, you might have to change that, like I said, just depending. But we're going to go back to the pump map. And as you can see, this vehicle's pump map was fully filled out on pump. And water meth, it's staying the same for now because we're on the first couple of renditions of the water meth injection. And you'll see in the log how the fueling is substantially less because the target fuel doesn't need to be as rich because we're injecting water meth, as stated before. So this is what the VE is looking like. And then if we go back down to timing, right, this is what the water meth timing looks like. And this is what the pump timing looks like. Now, the pump map was dynoed. I don't have the numbers for that, but the water meth map has not been dynoed yet, but we are working on that hopefully soon. So as you can see the drastic changes, especially in the top end when water meth is being applied. Now, the water meth system that we're using is the V3, right? So with the V3, if I zoom in right here, you have a boost safe, right? And then you have an arm switch. So you're going to hook up everything else as normal, right? That you're going to want to use with the water meth system as they advise, right? You have a boost hose, battery hookup, level sensor. It's important that you use the level sensor with this setup and that you have a good pump as well as a good solenoid right here. The solenoid we can control with Ignitron or you can control it with the AEM. I recommend using the AEM for this case just to keep it simple. But the two wires that you care about are the arm switch and the boost safe output. So we go up here to the top to inputs here. We're using pin 61 right here as push to pass. The reason is this vehicle is using aux 1 and 2 for other things. So aux 1 and 2, one of them is for anti-lag and one of them is for exhaust backfire on this particular car. Because it is a CAN-based cruise control stalk in this vehicle, push to pass was the only open output that the customer was comfortable with using. So like I said, use ECU pin 61 or you can use ECU 54 because of the wiring has a resistor in it, and I'll show you that here. If we go to appendix and pinout type C, if you scroll down, so this one is AC pressure sensor EGT, and it has a resistor in it right here. See, it has a pull-up resistor to 12 volts. So that's important, and same with pin 54 right here, as you can see. The other pins that are listed here and here do not have that ability. You'd have to install a resistor for them to read a ground output, right? Because the water meth controller, as seen here, this is boost safe is a ground. It's not a 12 volt switched, right? So it is a ground output. When it is grounded, right? When it is grounded, that means it is safe to boost. When it is not grounded, is not safe to boost, right? So safe to boost, grounded, not safe to boost, not grounded, right? So it means it's not putting a signal out. So that's the important part there. So as far as setup goes, right, we go to outputs here. On outputs, I've got the user-defined one on ECU 23 as water meth injection. So what you're going to do is install a relay, right? A relay is going to go to this ARM switch. So what happens is you're going to use a just a regular 12 volt relay, and you're going to use the ground side of that relay to the Ignitron ECU on whatever output pin that you want to specify. If 23 is taken up, you have a plethora of pins here to choose from, right? So what you're going to do is hook one of these outputs to the ground side of that relay, right? And then on the other side of that relay, you're just going to do a switch 12 volt. And then from the pin 30 normally on car relays is going to be the 12 volt constant, and pin 87 is going to be the switched output. And what you're going to do is put that armed output, that's this yellow wire right here, that is going to go to the load side of your relay, right? Your output side of the relay. So that when the ECU commands it to come on, it will arm the AEM system. So when it arms the AEM system, right, it's on, and it will come on at the specified boost that you have it coming on at, and then it will turn off at the maximum boost that you have at. So when it's at full tilt, and that's the important part here. That's how you retain progressive methanol control. So we scroll down, and we're going to go to our user-defined water meth output. So in this case, the customer wanted to only be on when race mode is active, and so we're going to set that to activate 1. Push to pass has to be active. So if the methanol level gets too low, the output from the methanol controller is going to shut off, causing this to be a 0. When this is 0 and it's not safe, what happens is it effectively turns the controller off because the arm switch turns off, and then it will revert from the water meth map to the pump map. So when it reverts from water meth map to pump map, it lowers the boost, and I'll show you guys in a moment what that entails. So this is the basic setup here. So I have the water meth and pump map matched, because if you go here to fuel blending configurator, there's some things that are going to need to be reused, right? So if you want to have blending between the two maps, right? Because it's the same fuel, you don't really need to change some of the stuff here, right? So we're just going to close that out because it's per setup for all of that jazz. So 0 is not active here, and 100% is active, right? Because it's just a relay. So there's no pulse width against the relay for the arm switch. It's either on or off, right? And that's all you need. So then we go to boost control, and we can see boost control pump, and then we see water meth. It's a little bit more boost on the car, and preset 2 should be the same. So when it switches to water meth, because of the presets, the water meth map is a little bit more aggressive, so it's more boost. And if you look at the timing map for this particular vehicle, the timing map is increased to 330 kPa, whereas the pump map is only at 300. So our maximums changed here. So that's the important part. And speaking of maximums, there's also in target lambda the changes here. So it's going from 0.785 and it's going to 0.80. And the reason it's so rich on this vehicle, just due to it being a front-wheel drive vehicle, and the exhaust manifold that's being used is known for higher EGTs. So in the attempt to keep the EGTs lower, instead of it being red hot, injecting more fuel on a regular pump map is just trying to help cool everything down, just because it's such a tight space and the exhaust manifold just holds so much heat. And that's just a little trick that I have that helps that out a lot. So that's just something from earlier there, and you can see the differences as shown. But going back to our mapping, right, in our previous video that I showed how to do the CAN messaging. this vehicle was the same thing. So race mode's on when the cruise control stalk is on. Now, we have aux1 as the like rolling anti-lag button in this vehicle and the set button. So cruise control still works, but if we go up to rolling anti-lag, it might, yeah, so rolling anti-lag is enabled auxiliary 1. So when aux1 is pushed, the vehicle will do a rolling anti-lag, right? So that's why I said it can't be used to say that the water meth is enabled. So this car has rolling anti-lag. And in preset selector, we haven't really set anything up yet, but it's just 1, 2, and 3 for now. But that's the basis of how to set up water meth control, is you've got to match both of these, because in fuel blending presets, you can have auxiliary user defined outputs. You want blending enabled on that one because you want both the maps to stay the same. Because if you don't, sometimes it will turn off the water meth control for whatever reason. It just says that output's not active at all. That might have been a glitch in 1.27, but in 1.28, I believe it is resolved. So, like I said, you guys can take a picture of this, use it how you want, and I'll post a little bit better description of this. So, boost output here to pin 61, and then this goes to a relay on the yellow wire. Now, I think I did make a post on the Ignitron users group on Facebook on how to do this, and if you're interested on that, join the group, look at it, and you guys can get a little bit better understanding of how I did everything in that write-up, because instead of a video, it's a typed write-up. One last thing I forgot to add in this video, hope you guys stayed, is right here. So as you can see, when the car is coming up on it, right, it turns off for about a second, right? And we go to sensors RPM, right? It's at the specified RPM to turn on, but we scroll all the way down to user defined. It's kicking out because push to pass turns off, which means the boost safety came on. And the boost safety usually is coming on, like I said before, because of a level switch issue. And due to this car being front wheel drive and it mounted in the back, when it's spinning and then instantly hooks up, it causes the car to jolt back, right? Like we've all seen front wheel drive cars do. And that water meth, where the sensor's located, it caused it to dip out. So when that sensor dips out, it cuts the water meth control out. But see how it's on the whole time, regardless if this is on or not, right? Because it's on this file, whether that meth is on or it's not on. So just something to be cognizant of. Now, if you guys are liking the style content on the how-tos and the in and outs of Ignitron ECUs, please say it down in the comments or just DM me, say, your critiques. It's important to me that we find out the best ways to move forward with this ECU, as I am in the States and a majority of the people that are on it are out in Europe. And I want more people in the United States to run this ECU and understand this ECU, because it is an amazing ECU for the 1.8Ts. So, like I said, just let me know, and I greatly appreciate your feedback. Thank you.